Hello everyone, this is Matthew Sene. Please watch the radar video before you watch this video. The radar video has some material that will help you to understand how the SETI array functions. I'll see you back here when you're through with it over there. Are we alone? Are there other intelligent species besides ours? Would they try to communicate with us? What would they say? We will probably not know until we make more effective efforts to detect their transmissions. Anyone searching for intelligent signals of extraterrestrial origin from any potential source must answer the following questions. What to observe? When to observe it? How long to observe it? At what frequencies to observe it? How often to re-observe it? A source that is silent now may become active in the future. Some of the answers to these questions are under the control of the searcher. Others are imposed upon the searcher by nature. This is a chart of the electromagnetic spectrum. I think it's a good idea to pause the video now so you can study the diagram for a bit. The second scale from the bottom is the frequency scale. We are interested in the region from 10 to the 9th to 10 to the 10th waves per second. Instead of waves per second, astronomers say hertz. 1 hertz is 1 wave per second. So the frequencies that interest us are from 10 to the 9th hertz to 10 to the 10th hertz. 10 to the 9th hertz is 1 gigahertz. 10 to the 10th hertz is 10 gigahertz. As you can see, microwave ovens operate in this region, so we want to be far from them. Let's have a closer look at the electromagnetic spectrum between 1 and 10 gigahertz. Here is a diagram of the electromagnetic spectrum between 0.1 and 1000 gigahertz as seen from the surface of the Earth. The horizontal axis is the frequency axis, and you can see it's labeled with the abbreviation for gigahertz. The vertical axis is labeled in degrees Kelvin, but you should think of that as how much electromagnetic interference and how much electromagnetic noise there is. The bottom of the scale is a low noise, and up near 1000 at the top is high noise. We want to find a quiet place in the electromagnetic spectrum that intelligent extraterrestrial species may want to use for their transmissions. The least amount of noise appears to be from 1 to 10 gigahertz, where there is a broad trough in the electromagnetic spectrum that's quieter than other areas. In the past, this region of the electromagnetic spectrum was inhabited only by radio astronomers, various radars, and NASA spacecraft, but with cell phones, it's no longer as quiet as it once was. The vertical tick marks in the trough labeled H and OH are of special interest. H is the symbol for hydrogen, the lightest and most abundant chemical element in the universe. O is the symbol for oxygen, something we constantly need. OH is the symbol for the hydroxyl molecule. The tick marks indicate the frequencies at which hydrogen and the hydroxyl molecule radiate in interstellar gas. The space between the stars is not empty. When hydrogen and the hydroxyl molecule meet, they form H2O, water, something else we require to live. As far as we know, water is vital for all life, both terrestrial and extraterrestrial. The small range of frequencies between the H and OH emission frequencies is known as the water hole, because, analogous to the behavior of creatures on Earth, any extraterrestrial species may congregate in this frequency range to listen for messages from or to transmit messages to other species. As suggestive as the water hole is as a place to search for radio signals from alien civilizations, there is nothing to prevent extraterrestrials from transmitting in the 1 to 10 gigahertz frequency range, and some good reasons they would want to, that we do not need to discuss now. If we search for radio signals of intelligent origin from other sentient species, we must plan to observe at all frequencies from 1 to 10 gigahertz. The reason I'm placing such emphasis on the water hole is because the radar frequency is just to the left of the hydrogen atom frequency. It may be possible to tune the radar receiver so that it can also receive any signals broadcast in the water hole. We can search for alien life at the same time we're searching for near-Earth objects. It's 2 for 1, a twofer. Later, other arrays could be built to cover the entire frequency range from 1 to 10 gigahertz. What would a transmission from an alien species look like? When I say, what would it look like, I don't mean this. We must first detect that a signal is present before we try to extract the information from it. Here is how we make the detection. Here is a radio telescope's view of some gas clouds along the line of sight of the telescope. A device called a spectrometer, made from electronic components, spreads the data out along the frequency axis in much the same way as a prism separates white light into a rainbow of colors. We can see evidence of 5 or 6 clouds with a lot of internal turbulence along our line of sight. This spectrum is produced by clouds of hydrogen gas in the spiral arms of our Milky Way galaxy. Let's see what the alien transmission might look like among these clouds of gas. There it is. You can immediately see there's a distinct difference between the broad, naturally occurring lines and the very narrow, artificial line of the alien transmission. The aliens may do some things to further attract our attention to their transmission line. How about this? Or this? Or even this? So the lesson here is, if you want to see this, you must first find this. Afterwards, we can use standard signal processing techniques to decode the signal and display the information that it contains. If you've already watched the video on radar, you know what's on the way. In this diagram, the sky revolves around the north celestial pole. Objects generally rise in the east and set in the west. The darker blue area is the receiver beam field, similar to the beam field for the radar, but with one important exception. The radar receiver beam field followed the transmitter search beam across the sky. However, the SETI receiver search beam field is fixed in space. It does not move. The sky turns above and objects drift through the beam field. Each of the receiver beams in the receiver beam field will have its output directed to a spectrometer. The spectrometers will spread the data out along the frequency axis, and we will be able to pick out any lines that may be of extraterrestrial origin. That green object in the southeast is a simulated SETI source. That SETI source is in the receiver beam field now. If it's transmitting, it will be detected by the spectrometers. We can form another receiver beam that will move in space and track the SETI source across the sky. This array can observe billions of solar-type stars per day, and billions of other types of stars too. From a latitude of 30 degrees north, the array will be able to see about 70% of the universe, all of which will be re-observed daily. In the novel Contact by Carl Sagan, there is described a gigantic irregular polyhedron the size of a planet. The polyhedron is in orbit around the star Vega. Vega is the brightest star in the constellation Lyra, the Lyre. Lyra can be seen during summer evenings in the northern hemisphere. Vega, together with Deneb and Altair, form the summer triangle. Vega is larger, brighter, and hotter than the sun. That makes it a little blue, and it rotates so fast that it bulges out at the equator so that it has an elliptical cross-section. At the left side of the sun, you can see our trio of Earth, Neptune, and the polyhedron, all to scale. The surfaces of the polyhedron are covered by millions and millions of large dish-type radio telescopes. If you use big dishes, then you do need millions of them because they have tiny fields of view and the sky is very, very big. On page 20, one of the dishes moves a bit to point at a newly discovered source. And of course, we all know that the source is the Earth. To simplify what follows, I'll make the polyhedron a big cube. It's big, but not as big as the polyhedron in the book. Here is my representation of one of the cube faces. There are 1,024 blue dots on the cube face that represent steerable dishes. Cubes are okay, but let's have a look at a tetrahedron. A tetrahedron is sometimes called a triangular pyramid. A tetrahedron is composed of 4 equilateral triangles. In the illustration, we are looking full face on to one of the triangles. I put that little red sphere in there to help with the perception of the tetrahedron as a space-filling object. It's 3D. In this illustration, we're looking down on a tetrahedron from the top. It's no longer a space-filling frame. It has 4 faces, one of which we can't see. On each of the 4 faces, there is a circular phased array. That's what those blue disks are. Their shapes have become distorted because of our perspective. I've made the blue array disks and the tetrahedron faces somewhat transparent so you can see the circular array on the bottom side. The dishes on the cube faces are the size the aliens think they need to detect leakage radiation from other civilizations. Leakage radiation is what we send into space without thinking about it. It comes from things such as radio stations, TV stations, cell phones, and various types of radar. Each of the phased arrays on the faces of the tetrahedron have the same diameter as the dishes on the cube face. A planar phased array that has the same diameter as a dish will have the same detection limit as a dish. And the array can see much of the sky at once, while the dish can only see a very tiny part of the sky. Each face of the cube has 1,024 dishes. Multiply that by 6, and the entire cube has 6,144 dishes. Divide by 4 for the arrays on the faces of the tetrahedron, and you find that each array is doing the work of 1,536 dishes. The dishes are all staring at different tiny areas of the sky. But the 4 phased arrays on the faces of the tetrahedron can see the entire sky. They can see everything at once. That is the power of an all-seeing phased array. The tetrahedron is shown to scale at the upper left corner of the cube face. Look at that little tiny thing up there. It's doing the work of the thousands of dishes on the 6 faces of the cube. From this visual example, you can extrapolate to the millions of dishes on the surfaces of the planet-sized irregular polyhedron in the novel contact. In that case, each of the arrays on the 4 faces of the tetrahedron would be doing the work of millions and millions of dishes. And the tetrahedron is a lot smaller than a planet-sized irregular polyhedron. This isn't an implied criticism of Carl Sagan. It's just that if you've been raised in the dish tradition, you see them everywhere. If phased arrays like those described in this video had been available then, he would certainly have used those instead of the planet-sized, dish-covered, irregular polyhedron. What about the answers to those questions at the beginning of the video? What to observe? Everything. See it all. When to observe it? Whenever you can see it. How long to observe it? Whenever it's in the beam field, and perhaps even longer. At what frequencies to observe it? All of them from 1 to 10 gigahertz. How often to reobserve it? Daily. If there are intelligent aliens beyond our Earth and they want to be found, these arrays will find them, provided there is enough money to make the arrays as large as necessary. If no alien signals are detected, there are 3 conclusions that can be drawn. 1, there are no broadcasting aliens. 2, there are broadcasting aliens, but they're not broadcasting in our direction just now. And 3, the arrays are too small. To see the entire sky, we should have 1 set of arrays in the northern hemisphere and 1 set of arrays in the southern hemisphere at minimum. So that's my big plan to try and answer one of the most profound questions of human existence. The radar would be my contribution to ensuring we're always around to receive that answer should it ever arrive. Thank you for your time and attention. How long until our question is answered? No one knows. But we shall continue to search.